Today I will be presenting our IRE major project, which is figuring the weirdness score and ranking weird or bizarre news stories. Here are the contents that I will be covering in the video. First of all, our problem statement. What we are trying to do is classifying a given news article as weird or normal news and also predicting the weirdness level of these news. Here are some of the challenges that we faced during our project. The major challenge that we faced was finding out the most important features among the features that we extracted from the title of the news article, and also manually annotating the weird news depending on the weirdness of the articles. So the final deliverable is implementing a system which classifies a given news article into weird or normal, and also providing a title weirdness filter that will rate the weirdness of the article. So what is a weird or a bizarre news? It is a news article which is so strange that users might question its credibility. It is usually very rare and unbelievable. The motivation behind detecting a weird news article is it keeps the boredom away, and also many news aggregator websites use it to gain readers' attention and increase their viewership. Here are some of the examples that are extracted from Ripley's and Router's website. So there has not been any prior work directly related to weird or bizarre news. However, we find clickbait detection and fake news detection closely related to our topic. From the previous 2 years, there has been many publications in these domain. Now I'll talk about the dataset that we have. We have around 1,15,000 news articles, and amongst them 67,000 are weird and 47,000 are normal news articles. The dataset that we have includes the URL of the article and also the title of the news article. Here are the solutions that we propose. We use SVM random forest, logistic regression, deep neural nets, RNNs, and attention along with RNNs. The tools used by us are Python, Flask, Spacy, scikit-learn, Keras, and Theano. The first phase of our project was finding the scope of the document and understanding and building a prototype for our project. We discussed on various applications, challenges, tools, and the related work. Here is the overall architecture of our project. So phase 1 was classifying a given news into weird or normal news. In this, we have the dataset containing normal and weird news. We did feature engineering and extracted features from the dataset. After that, we apply a two-class binary classifier to classify the news as weird or normal. The second phase of our project was ranking the weirdness. That is, given a weird news article, we had to rank it from 0 to 3 depending on its weirdness. So here we apply a n-class classifier on the dataset that we annotated. So the second phase of our project, as I told, was classifying a news article as weird or normal. In this, we extracted some of the following features. We extracted the title length, number of nouns, number of stop words, verbs, frequency of co-occurring words, TF-IDF vectors, the pause tags, n-grams, and we also used word embeddings like the pre-trained word-to-vec glove embeddings for the RNN part. Here are the results that we have. So using RNN and glove, we had the best accuracy in BILSTM and attention network, that was around 87.4%. We also tried varying the size of the input, that is the number of words of the title taken as input for the word embeddings, and we found out that more the number of words, the greater the accuracy. Here are the results for the TF-IDF vectors. Here are the other models that we used for classifying the news. So the third phase of our project was how to rank the given news articles on the basis of their weirdness. For this, we did not have the data, so each member annotated around 500 news articles with a rating of 0 to 3, where 3 represents highly weird and 0 represents conventional news. After the annotation part, we found out that all our ranks were different, and we had to we used two different methods to do the ranking part. First, we used the average rank, in which we averaged all the four ranks, and second was the majority rank given by us. The approach used by us is we pose this problem as that of a multi-class classification problem. So each news article is given a label depending on the weirdness of the article. After that, for a new article, we just have to classify it into the four classes depending on its weirdness. So here are the results we have. So using RNN and Glove, we found out that bile esteem plus attention was giving around 76% accuracy, while the using TF-IDF neural net was giving around 79% accuracy, which was the best among the ranking part. Here are the other models that we used. So for all the models, we used 80% of the data as training data and 20% as the testing data. And also we can see that for the classification part, the RNN plus the pile esteem plus attention was giving the maximum accuracy, while in the ranking part, the neural net plus TF-IDF vectors was giving the maximum accuracy. We have also created a small application which, when given a title, it identifies whether it is a weird or a normal news. And if it is weird news, it tells the weirdness score of the article.
Here we need to enter the title of the news. Let's take some normal news. This is a normal sports news. Yeah, it is showing normal news. Let's take some other news. This is the weird news, and so it is showing 50% weirdness. Let's take some other. Yeah, it is a weird news with 75% weird.
Here are the references that are the research papers that we used and the links of our website and the GitHub page. Now we'll be presenting our demo.